This is the Semester 1 midterm review. So we're looking through here and we want to give two other names for line AC. So we could call it AB with arrows above its head, or we could call it BC with arrows above its head. 2 points along that line. You could even change the letters in the opposite order. But a real neat way also is to use the word line and the small case letter that's next to that line. Name 3 points that are collinear. Those are 3 points on the same line. So that would be points A, B, C, or points E, B, F. And we could separate those with commas because they're separate points. Give another name for plane P. Notice that it's a capital letter. It's bold, actually. It's darker than all the rest. There's no dot near it. There's not a point. It's the name. Kind of like the little K is the name of the line. The capital P is the name of this plane. Another way to name it is with 3 points that are not on the same line. So we could name it ACD with no commas in between. Plane BCD would be another way to name that same plane. Or plane ABD would be another way to name that same plane. Give another name for ray CB. I know it's a ray because there's an arrow only at one spot. So another name for ray CB. It starts at C and it goes through point B. So what other point does it hit? It hits point A. So you could say CA, and that would be the same exact ray. Just like if you were shining a flashlight towards B, you'd be shining the flashlight towards A. Name 2 pairs of opposite rays. Opposite rays have to have the same endpoint. So we'd say BC. So it starts at B and goes through C. We could start at B and go through A. 2 rays that go in opposite directions. They form a straight line. There's no overlapping. We start with B in both cases, so that's called our endpoint. Another pair we could do is to say BE. That would be a ray. And BF. Notice I put the symbol above the letters. Name the intersection of line L. Here's line L and line AC. Their intersection. Line L is going right up through the middle of it. Line AC would be running on the plane. So their intersection is point B. Here we see that we have all these different points that are collinear. That means they're all on the same line. We have points C, X, Y, and Z that are on the same line. We have segment AB, which is the same as BC, which is also equal to CX. So we put a little tick mark to show that they're the same, and a little tick mark to show that they're the same. So they're all the same length. AD, they're telling us, is 54. XY is 22. And XZ is 33. So as we look here at the picture, we're trying to figure out what do we know for sure. We know these are the same length, but we don't know what CD is. There's no information that says that it's half. We know that this is 22, this is 33. That would make it, to figure out XY, we would, or xz, sorry, yz. To figure out yz, that would be a length of 11. Because 33, take away the 22, gives us 11. Anything with that same tick mark is 11. So this length is 11, that length is 11, and so is AB. So now this is 22, which makes this 32. Now we can go through and answer our questions. AB is 11, BD would be 32 plus 11, CY would be 11 plus 22, CD is 32, XC is of course 11, and CZ would be the 33 and 11 more to be 44. Use the picture to answer the following questions. What's the length of KL? Well, we're starting here at K, which is actually at negative 15, and we're going all the way out to point L, which is out here at 25. So we could count. We could say that 25 minus your negative 15, absolute value of that would be one way to do this. To say that this is 25 plus 15, which is a length of 40. Or most people would sit here and just count 5, 10, 15, 20, 25, 30, 35, 40. If you begin at point K, what is the coordinate that is 3/5 of the difference? So if we can break this down into 5 equal groups, what would be 3/5 of that complete length? Well, if we take the 40 and we multiply it by 3/5, we can either do some reducing or we can just do some multiplying. You could call this 120 divided by 5, and then 5 is going to go into that. We go in there 2 times, which is 10 with 2 left over, so it's a length of 24. It's 24 units away from the 15 to the right. So negative 24, negative 15 plus the 24 takes it up to the 9. 5, 10, 15, 20, 25, take away 1 because it's only 24, and that would be at the spot of the 9. You begin at the leftmost point. What coordinate is 1/8 of the total distance? So we would want to break this complete distance of 40 into 8 equal groups. So one way to do that is to look at the calculation of 40 divided by 8, which is 5. So if we go 5 units in, working towards the K, this is going to be 25 minus the 5 to give us, we're going to be at point 20. We have point E that is in between D and F. It's in between. It does not say it's exactly in the center. It's just in between. DE is 5x minus 3. EF is 3x plus 5. And the total distance is 66. So we have to look here and try to figure out what is the length of DE. So we could sit here and guess what it is. Maybe it is 16 and 50, or it's 60 and then 6. A whole bunch of options it could be. Another thing to recognize, are these two segments the same length? Do we equal them to each other? Or can we say that DE plus EF should equal DF? The two short pieces add up to equal the whole piece. So we say 5x minus 3, 3x plus 5, and that equals 66. That's 8x and a positive 2. Subtract your 2. and x is going to equal to 8. Now, doing the midterm, I'm sure that the 8 is going to be one of the options. You've got to be sure to answer the question every time. If you bubble in 8, you've done all your work right, but you get 0 credit on a multiple choice test. To get DE is 5 times 8 minus 3. 40 minus 3 is 37. EF is 3 times 8 plus 5. 24 plus 5 is 29. Together, that equals 66. On the next page, we're looking at this diagram. M is the midpoint. That tells us something. That tells us that PM is supposed to be congruent to MR. If they're congruent, we've said in our proofs, then PM equals MR. And we can plug in our values of 4x minus 12 equals negative 2x plus 21. Do the math across, and we get 6x. Add your 12 across, and that looks like that's 33. So x is going to be 33 divided by 6, which goes in there 5 3/6, or 5 1/2. Again, that's the length of x. But when it says find PR, that means we have to know what the total length is going to be. So 4 times 5 1/2 minus 12. We have 20 and 2. So this is 22 minus 12, which is 10. One length, PM is 10, MR is 10, so the total length of PR is going to be 20. We're going to find the coordinates of the midpoint. Well, there's a formula for the midpoint. You would want this on your note card. So we have x1, y1, we have x2, y2. Now you can plug in your numbers. Negative 3 plus 1 over 2, and we have 9 plus 3 over 2. Negative 2 over 2, 12 over 2. So our midpoint is going to be negative 1, comma 6. Another good way to kind of look at this is to make a sketch. And we know that we have one point at negative 3, 9. We have another point at 1, comma 3. So when we say negative 1, 6, that seems reasonable. It's there in between those. If it would have been positive 6, negative 1, we would have been not in between our two original points. We want to be sure that we're the midpoint if that's what it's asking for. This question here says that we're looking for the other endpoint. We're given an endpoint and we're given a midpoint. Again, a sketch is a great way to do this question. Positive 2, negative 3. Negative 6, negative 4. So that's our midpoint. And Q is our first endpoint. So if this is an endpoint and M is the midpoint, the other endpoint has to be the same distance over, approximately right there. One easy way to handle this is to recognize your 2 units over, and you have to go 6 units this way. So that's a total of 8 units to the left. You have to go 8 more. So you have to go all the way out to negative 14. And then we're up here at negative 3. Then we have to go to negative 4 to get even with the M. So we have to go to negative 5 to get even with our new endpoint. So that should be our new endpoint. Negative 14, negative 5. You can count it. But mathematically, we like to be a little bit more with calculations. We have our midpoint. So we have our x-coordinate and our y-coordinate of the midpoint. This is just our x and y. Using the same formula we had earlier, x1 plus x2 over 2, that's going to equal the x-coordinate of the midpoint. So we know that we have 2 plus x2 over 2 equals negative 6. 2 plus x2 is going to equal negative 12 when we multiply by the denominator. So that's going to give us x2 to equal negative 14. Subtract 2 gives you negative 14. y1 plus y2 over 2 equals the y-coordinate of the midpoint. So we're going to plug in the negative 3. We don't know what the other endpoint is, but we know the midpoint is at negative 4. So multiply by the 2. Add the 3 across. So when you add 3 to negative 8, you get negative 5. So our answer is negative 14, negative 5. It might make things a little bit more comfortable to count, but here's the math that can be done to help you calculate it specifically. On a multiple choice test, you could do it either way. The endpoints of two segments are given. Find the length. So you first need to know that the formula for length, which is the distance, is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So we're going to call this x1 y1, x2 y2, and we're trying to determine what its length is. So we're going to say the square root of 3 minus 5 quantity squared, negative 7 minus 1 quantity squared, so that's negative 2 squared, negative 8 squared. That gives us 4 plus 64, which comes out to be the square root of 68. Now we could put that into a decimal if we wanted to. Or right now, if we're just trying to see which one's bigger or if they're the same, we know that this is BC and its length is the square root of 66. It's a little bit more than 4. Our other distance, our x2 would be 5 minus a negative 3 quantity squared, and 9 minus 1 squared. That's going to give us 5 plus 3 and 8 squared. So that looks like that is 8 squared plus 8 squared. So really that is quite a bit longer. So this is the square root of 128. So the endpoints of the segments are given. Find each length. Tell whether the segments are congruent. Not congruent. One is the square root of 68, and the other one, which is called EF, is the square root of 128. We're given our triangle, our angle ABC. It's 123 degrees. We're going to find the measurement of ABD. That is this angle right in here.